Hello boys and girls, welcome to a brand new tutorial on how to create Minecraft in 2D. Now, this tutorial is going to be about the view, and this is a thing that you will encounter with every single 2D game. Yeah, well, not every single, but like most of them. So what I need you to understand is that this is our view, right? And let's say we want to follow a player, for example, the player in the middle. Now, of course, you might have a threshold where the player would go left, and then the view would go left, and then the player would go right, and nothing happens. And if the player moves here, then the view will go right. That's a possibility. You will learn that once you really understand what I'm going to do in this tutorial. So, you've heard it correctly. We are going to create the view and also the player. So let's get started. Let's open it up in Visual Studio Code. And I just created a copy. So I need to go there. A new version of Java is available, like I would care. So actually it is not episode 2, it is episode 3 already. So episode 3. Okay, so let me just npm run def and a thing will open here, right there, console log. Everything's correct, I think. No, I don't know. Hang on. I'm making too many videos right now. So yeah, blocks and grass side. Okay, and let's go here. Yeah, that's image. Okay, cool. So what I wanted to change was this. I don't like the fact that we are having an img property while it is a texture. So yeah, it's not really a texture, but like this is the img, but this is not. This is the texture. So we should change this texture, and we can change this to like image path or something, or leave it at image or image URL, something like that, or leave it like this. But yeah, I thought that we had to make texture instead of like, because it is an actual texture. So now if we take a look at our game data, at blocks, stuff like that, it is a texture. Okay, cool. So let's go to our game. Do we need anything here? Yeah, we do, because we are drawing to the app, right? The app has a view. Let me show you. This .app.view, and that will basically refer to app renderer view, which is our canvas. Okay, so we can take the width and the height of that canvas to create a view. But before we can do that, we actually want to pass it to our world object, because the game is not actually the world of our game, because we are generating a world inside our game, because our game also consists of a menu, maybe some later on we will add a texture importer, multiplayer options, stuff like that. There's a lot more going on in the game than only in the world. So we're just going to pass this .app to our world object. Now here we need to say app, and it is an application because it is a pixi application. So application from pixi.js, and then we also need to say public app is an application, and obviously say that this .app is an app. Great. Now what we can do is we can create the view, but we also need to create the player. So we gotta create two new files, one view, and we gotta place it in the scripts, not in the data scripts, and we gotta create a new file called player.ts. Yes, okay, cool. So what we can do now is we can say export class player like we always do, and give it a constructor, and then it has some properties. For example, it has an x, a y, a width, and also a height, and they're all numbers. And let me do this, and let's say this dot equals like that. And then obviously we gotta say public. Let's make it public because we will want to exit the x, and we will want to access the x and the y value outside the player object. But the player also has a sprite, so, and we're gonna make the sprite public as well because we want to access the sprite from the view or maybe from the world. And the sprite is definitely not a number, it's a sprite. So let us import sprite from pixi.js as well. Okay. And let's then say that this sprite equals new sprite because we're just gonna create a player here with one texture. We don't need to like insert it with, import it with data objects or stuff like that. We can just say this. So let's say texture from, and then we can just say, for example, src. Let's just grab a texture block because I don't have the player script, player sprite yet. So let's say assets, textures, blocks, and then let's say dirt.png. So our player will look like a dirt block. And texture is not here, so we gotta import that as well, right there. Okay, that's cool. So what we can do now is we can create the player. Okay, but let's create the view as well. So view, it doesn't have a sprite, it only has an x value, a width, and a height. Okay, so let's go to our world object here, and we have two new properties. One is going to be the player, which is a player object, and one is going to be the view, which is a view class. So now we can say this player equals new player, and we can basically do the same thing for the view. View. Okay, now let's just create the player on 0, 0, and let's give it a width of the block size width and a height of 2 times the block size. So we can say block size and block size multiplied by 2. So block size is so common that we can actually create a new variable here, but let's just say this game data block size for now. That's for now. That's temporarily. So let's create the view as well. Let's also create it as 0, 0. That's not the place where it's gonna be, but let's just do it for now. And then here we can say that the view width is going to be this dot app dot view dot width and this dot app dot view dot height. So we're going to refer to the view, which is an HTML canvas element, and then we're just gonna refer to the width. So that's basically gonna be 660 and 937. So yeah, when we refresh it and we go take a look at the game, we go take a look at the world, it now has a view and it has a player, and the player has a sprite as well. So we can actually draw the sprite on the screen right now by saying that the sprite dot width equals the width and also equals the height. Width, it's th, right? Width, yeah, it's th. And for height it's ht. Man, I'm having trouble with this. Did I do the same thing here? Yeah. Is it really width? Width? Oh my god, I'm so stupid. Width, 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 width. Okay, I hope I'm doing this right now. Okay, and yeah, then you might think, let's also assign the X and Y position to the sprite, but then you got to remember this. This right here, so let me just draw a circle right here. This position right here, that is the position 0, 0, right? On our canvas. Because this is going to be position 0, 0 for the player. And then you can say that, for example, this is going to be a bedrock layer, bedrock, more bedrock, 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 and then a couple stones, and then eventually we will get like mountains and stuff like that right here, maybe some sea, you know. So that 0, 0 position right here is only for our canvas HTML element. So we gotta work around that. We gotta say, when we assign the sprites and stuff like that, and the width, yeah, talk about the width. Let's just make the width right. The width is going to change. I mean, the width might change, and as well as the player X and Y position, they're definitely going to change. So we got to go to the world here, and we got to create this ticker right here. And what this will do is this will be based on the window dot what is it, requests frame, animation frame, and it will make sure that whatever happens inside this will happen every time, again and again. So this is very useful because the width of the view, this.view.width, needs to be the same as the width of the canvas, and the same goes for the height. While I'm thinking about this, we might want to change this into a window.on resize, like that. We might want to do that. Let me take a look at that, if that works. We gotta say console.log this.view. So that definitely works. Yeah, that's good. Because if we were to add it in here, that means it would happen every time, and now it only happens on a resize. So yeah, instead of using this, we could also say like private resize, and then private resize equals void, like that, and we can just put it in here, and then window.on resize equals this.resize. So this probably works as well. Let me check it out. Yeah, so this works as well. As you can see, the width is starting to decrease, and now the width is going to increase. So that definitely works. So that's great. So now we have added an event listener on a resize window to become this resize. So we don't have to put it into the ticker anymore. Now the ticker is going to always happen. So we can actually do that with the ticker as well. So why don't we do private update void, and then put the ticker in here, and we can just say this.update. No, we should probably say this. This.update, is that correct? Type void. Yeah, so this works. Cool. So what we can do now is we can draw the sprite of our player on the screen to be exactly in the middle. So what we got to do is we got to say this.view.x equals the player.x multiplied by this.game data.block size. Now this is getting out of hand ridiculously fast. So we got to say this dot block size. Let's make it block size bs, and it is a number, and it's going to be referring to this one. So bs. Okay, cool. And then we got to say minus this dot app dot view dot width, which is basically the same as this dot view dot width, but then multiply by 2, because we want our player to be in the center of the screen. We can do the same thing for the y values here. Let's say the height. Now we actually want our player to be centered horizontally, so we gotta say player.width divided by 2, of course, this player. Now this player is getting out of hand as well, so why don't we say p for player, and we say player is the player. Then we can change this the player with p. Okay, cool. And same goes for view actually, so view, and then we can say this dot view, v, and v. Not here, because we want to assign this dot view dot x. Okay, I bet it works if we put v in there, but to get clear here, so let's say this dot player dot sprite dot x equals p.x multiplied by block size minus view.x, and the y value of the sprite is going to player. Well, this is already bullshitting again, because this is not very clear, so we might want to change it like this. Like that. Okay, cool. So now, if I'm correct, we have drawn the player onto our screen in the middle, but we haven't added a sprite yet. So we do need to make sure that we add the sprite. So this dot app dot stage dot add child, this dot player dot sprite, and now we've successfully added the sprite to our game. And as we can see, it's perfectly in the middle. So the y values are not exactly in the middle, and that is because the bottom here needs to be 0. Okay, we can actually draw x and y value to be in the middle. Why don't we do that? That's perfectly centered, so why not do that? Okay, cool. Yeah, nice. So now it's in the middle. Yeah. Okay, so we've successfully created a view and a player, stuff like that. We can now say, for example, this is the player dot x plus plus, and if we would console log this the player now, we would see that the player is actually moving on the x-axis. So yeah, and is the view going with it? Yeah, definitely is. I believe it's moving a bit faster because of course it is multiplied by the block size, because this value 712 is actually block number 712 on the x-axis. So this definitely works. I'll see you guys on the next tutorial. The next tutorial is going to be about the actual world. So we will fill up the world, and we'll start right away with the chunk system and fill those chunks with blocks and get a beautiful terrain generation started. Okay, thank you guys for watching. Make sure to like, subscribe, check out my Twitter profile, check out my Patreon page, and hit me up with suggestions down in the comments below. And yeah, check out the GitHub repo, and I'll see you guys in the next tutorial. Ciao.